Testing. Hello, Math0092. We are beginning with section 3.5 and actually might go beyond that with this lecture today. I'll label it appropriately when we publish. Well, we were talking about fractions. Getting acquainted with fractions, knowing that in fractional form we're looking at a numerator and a denominator, even whole numbers like 5. We can have a 5 over 1 as an equivalent actual fraction with a numerator and a denominator. We talked about proper fractions. That's when the numerator is less than the denominator, and improper, not proper fractions, improper fractions when the numerator is greater than the denominator. So we have 1 whole pi plus a little bit, a fractional part. So I brought my measuring cups today. And we're all kind of familiar with measuring cups, to kind of demonstrate that obviously this measuring cup is smaller than this one because it fits in it. And this measuring cup is smaller than this one because it fits in it. But this cup is too large to fit inside, so it must be larger. So let's just pick up these measuring cup values. The first cup is 1/3. Next, I have 1/2. And in my group of measuring cups, the next size is 2/3. And then there's a 3/4. And then I have 1 whole cup. So let's see if we can determine with our knowledge of mathematics which of these fractions is greater and place in order. Well, we know that when we're comparing for the order of fractions, we again have to have something common to both. So we really do need to have a common denominator. 3 and 2, that'd be 6, and times 3 is 18, but 4 doesn't go into 18. 6 and 4, that'd be 24. They all go into 24. Let's see, 3 goes into 12, 2 goes into 12, 3 goes into 12, and 4 goes into 12. How about 12 as our common denominator? So we're going to convert 1/3 to 12s. That'd be 4 times 3 is 12, and multiply the numerator by 4. Convert 1/2 to 12s. That's 6 times 2. So I'll multiply my numerator by 6 as another name for 1. Multiplying by 1 does not change the value of your number. In fractions, of course, it does change the way it looks. 3 times 4 would be 12. So I'll multiply the numerator by 4. 3/4 to 12s. Let's see, that's going to be 3 times 4. Multiply the numerator by 3 as another name for 1. And 1 converted to 12s, well, the 1 is a whole number, 1 over 1. I'm going to have to multiply by 12. 12 over 12. If I multiply the denominator by 12, I'll multiply the numerator by 12. Here, multiplying denominators, I get 12s. That's 4 times 1 is 4. 6 times 2 is 12s. 6 times 1 in the numerator is 6. Denominator, I have 12s. 4 times 2 is 8 12s. 12s for the denominator. 3 times 3 is 9. And 12s for the denominator. And 12 times 1 is 12. Now we compare numerators. Once we have a common denominator, we can compare order by comparing the numerators. And 4 is less than 6, so yes, sure enough. And 6 is less than 8. 8 is less than 9, and 9 is less than 12. So we are assured that our 1/3 cup is less than our 1/2 cup, which is less than our 2/3 cup, which is less than our 3/4 cup, which is less than 1 whole cup. So sometimes it's kind of fun to interject some of these visuals. I hope that it helped with comparing our measuring cups to determine that we had the right sizing and in order. Well, then with section 3.5, we are looking at addition and subtraction using mixed numerals. So a mixed numeral, we have a whole number and its fractional part. So 1 5/8. Here's a whole number and its fractional part. We're going to add 3 1/8. Irregardless of how it might be written, I always columnize, get my fractions in a column and get my whole numbers in a column. To add or subtract fractions, we need a least common denominator. It is a common denominator, so we can keep the denominator and add the numerators and get 6/8. And I can add my whole numbers and get 4. Remember, we always simplify fractions by looking for another name for 1. Let's see, 2 goes into the numerator and the denominator, both are even. So I get 4, 2 goes into 6 3 times, and 2 goes into 8 4 times evenly. So our answer is 4 3/4. Let's try another, adding mixed numerals, 2 3/10 plus 5 1/10. I columnizing my fractions and my whole numbers. I do have common denominators, so I keep the denominator and add the numerator and get 4/10. Adding my whole numbers, I get 7. But we're always going to simplify if possible by looking for another name for 1. And I see that 4 and 10 are even. I'm going to divide each by 2. 2 goes into 4 evenly 2 times, and 2 goes into 10 evenly 5 times. And bring down your whole number, 7 2/5. So looking to add mixed numerals when we have a whole number portion plus a fractional part, we still need to make sure that we have a least common denominator. In this case, I'm adding mixed numerals, a whole number portion plus a fractional part, but I do not have common denominators. So I'm going to convert 5 2/3 to 6. 3 times 2 is 6. So I'll multiply the numerator and the denominator. And I'll get 5 4/6. Bringing this across, I have 3 5/6. It was already in 6. I didn't have to convert. Now I have a common denominator, so I can add my numerators all over my denominator and add my whole number portion. And I get 8 9/6. But 8 9/6, 9 is greater than the denominator. So I have another whole pie in there. 8 plus 3/6 plus 6/6. 3 plus 6 is 9 all over 6. So I just broke 9/6 into however many whole parts of 6 I have, plus its fractional part. Now 6/6 is really another name for 1. So 1 plus 8 would be 9, and I still have the fractional part 3/6. And of course, we look to simplify. And 3 will go into 3 and 6 evenly. 3 goes into 3 once, and 3 goes into 6 twice. So my answer is 9 1/2. So this is that improper fraction where we have a whole number portion built in to the fraction itself. This is a whole number plus a fraction part. And breaking out 6 over 6 is a whole number, but 3 plus 6 is actually 9/6. So I'm breaking out that whole number part so I can add 1 to my whole number and get 8 or 9 and simplify. Let's try another one. 10 and 5/6 plus 7 and 3/8. Well, we have 6 and 8. We want a least common denominator. This is 2 times 3, and this is 2 times 2 times 2. I'm going to need the first column factors, 2 times 3. I have a factor of 2 yet. I need another factor of 2, not yet represented, and another factor of 2, not yet represented. That's 6 times 4 is 24. So our least common denominator is 24. So I'm going to convert 6 to 24ths and 8 to 24ths. So I have 10 plus 5, 6. 6 times what is 24 would be 8. So I'll multiply the numerator by 8 as another name for 1. And I have 7 and 3/8. I need to convert that to 24ths. 8 times 6 is 24. So I'll multiply the numerator as another name for 1. I made a mistake here. I was going to make that a little larger number than what it really was. 6 times 4 is 24. There you go. And 8 times 3 is 24. So I'll multiply by other names for 1, and bringing this down here, I get 10 and 20 24ths plus 7 and 3 times 3 is 9 24ths. Now I have a common denominator, so I can keep the denominator and add the numerators and adding my whole numbers. Now looking to simplify. I see that I have an improper fraction again. My numerator is greater than my denominator, so I want to rewrite this. 24, I'll get 24 over 24 for 1. And what's left? 24 from 29 is 5. So 24 plus 5 would be 29 24ths. I just broke it apart, so I got my whole number portion there. And this is another name for 1. So 1 plus 17 will be 18 and 5 24ths. Okay, subtraction. When we subtract mixed numerals, 7 and 3/4, and I'm going to subtract 2 and 1/4. Well, I have common denominators. Remember, when we add or subtract fractions, we think about the piece of pie, and they have to be cut into the same wedge. So we have to have a least common denominator. We do. So I can keep the denominator and add the numerators. But I guess I'm subtracting, so I get 2. 1 from 3 is 2. And 2 from 7 is 5. We always, again, look to simplify. Looks like 2 will go into both the numerator and the denominator evenly, so I get 5, and 2 goes into 2 once, and 2 goes into 4 twice for 5.5. We're subtracting again, 5 and subtracting mixed numerals. 9 and 4/5, and we want to subtract 3 and 1/2. I don't have common denominators this time, so I'm going to have to convert to a common denominator. 2 and 5, and the least common denominator is what we're looking for. That's 1 times 2 and 1 times 5. I'll need that factor of 2. Now I'll need another factor of 5. Our least common denominator is going to be 10. So converting 4/5 to tenths, 5 times 2 is 10. So I'll multiply the numerator by 2 as another name for 1. And subtract 3 and 1/2, but I'm looking to convert halves to its even equivalency in tenths, so that's going to be times 5, and I'll multiply the numerator by 5 as another name for 1. Now I have 9, and 5 times 2 is 10, 4 times 2 is 8. We're going to subtract 3, and converting to tenths, 2 times 5 is 10. And 1 times 5 is 5. I do have common denominators now, so I'll keep the denominator and subtract 5 from 8 and get 3/10. And subtract my whole numbers, I get 6. I can't simplify this any further. My answer is 6 3/10. Sometimes when we subtract fractions, we need to borrow. So I have 7 and 1/6, and I want to subtract 2 and 1/4. I need to find a common denominator, and 4 goes into 12 and 6 goes into 12. So we're going to convert 7 and 1/6 to 12ths. So that's going to be times 2. 6 times 2 would be 12, so I'll multiply the numerator by 2 as another name for 1. And subtract 2 and 1/4. And I need fourths to be converted to 12, so I'm going to multiply the denominator by 3, so I'll multiply the numerator by 3. And I get 7, and it's going to be 12ths. 6 times 2 is 12, and 1 times 2 is 2. I'm going to subtract 2, and 4 times 3 is 12, and 1 times 3 is 3. So 7 and 2/12, and we want to subtract 2 and 3/12. But I can't subtract 3 from 2. So I'm going to borrow. Now think about this. Here's 7, and 7 is equal to 6 plus 12 over 12. So I'm going to rewrite this as 6 plus 12 over 12, which is 7, plus I still have a little bit, 2/12. So 6 plus 12 over 12 plus 2/12 is the same as 7 plus 2/12. And I'm going to subtract 2 and 3/12. So now in the 6 plus 12 over 12 plus 2 over 12, I have a common denominator, so I can add and get 14/12, which is an improper fraction, but allows us to maintain the equivalency and subtract. So now I have the same denominator. 3 from 14 would be 11/12, and 2 from 6 would be 4. My answer is 4 and 11/12. So borrowing with care. Next, we're looking at an application problem. Widening a driveway. Sherry and Woody are widening their existing 17 1/4 foot driveway by adding 5 9/10 feet on one side. What is the new width of the driveway? So we have our 17 1/4 feet for the original driveway, and we're going to add 5 9/10 feet. And we want to find the new width. So adding the existing driveway width plus the expansion, which is going to be 5 9/10 feet, we will find the width of the end result. But we're going to have to find a common denominator. And 4 times 10 is 40, so let's try that. 17 1/4. 4 times 10 would be 40. Multiply the numerator by 10. And 5 9/10, we want to convert to 40th, so I'm going to multiply the denominator by 4, multiply the numerator by 4. So I have 17 and 4 times 10 is 40. In the numerator, I have 10. Plus 5, and in the denominator, I have 40. In the numerator, I have 36. I have common denominators now, so I'm just going to add the numerators all over my common denominator and add my whole number portions, and I'll get 22. And of course, we always look to simplify. I see this as an improper fraction, so I'm going to determine 40 over 40 plus 40, that'd be 6/40. So 40 plus 6 is 46/40. But 40 over 40 is actually another name for 1. That's my improper fraction. 1 plus 22 would be 23. And what's left? 6/40. And again, looking to simplify, finding other names for 1. 2 goes into 6 and 40 evenly. So I have 23. 2 goes into 6 3 times, and 2 goes into 40 20 times. So the addition will make their driveway 23 3/20 feet wide. On October 18, 1968, Bob Beamon set a world record of 29 3/16 feet for the long jump, a record that was not broken for nearly 23 years. This record-setting jump was significantly longer than the previous one of 27 19/48 feet, accomplished on May 29, 1965, by Ralph Boston. How much longer was Beamon's jump than Boston's jump? So we are comparing, we're looking for the difference. How much longer? So we want to compare Beamon's jump to Boston's jump. And Beamon's jump was 29 3/16. And Boston's jump was 27 19/48. We're comparing, we want to find how much longer, so we're going to subtract, find the difference. But we need to find a common denominator. I'm going to check my calculator, but I think 16 times 3 is 48. So I'm going to use 48 for my common denominator and convert 29 3/16 to 48 by multiplying the denominator and the numerator by 3 as another name for 1. So now I have 29, and 16 times 3 is 48, and 3 times 3 is 9. I'm going to subtract 27 and 19/48. Well, I have my common denominator, but I can't subtract 19 from 9, so I'm going to have to borrow. And I remember that 28 plus 1 would be 48 over 48, plus my little bit of 9/48. So I've converted 29 to its equivalency 28 plus 1. I'm still subtracting 27 and 19/48. So in the numerator, I have 28, and 48 plus 9 would be 57 all over 48. I'm going to subtract 27 and 19/48. I do have my common denominator, and I can subtract 19 from 57. 19 from 57 is 38, and 27 from 28 is 1. Always look to simplify, and I have 2 even numbers, so I know 2 will go into both evenly. So 2 goes into 38 19 times, and 2 goes into 48 24 times. 19 is prime, so I have 1 and 19/24 feet longer was Beeman's jump than Boston's jump. Okay, that completes section 3.5. We'll continue with the next section soon in lecture. But for now, be sure to return to D2L Brightspace for all details regarding this chapter 3, its homework, assignments, tests, and due dates. And remember that each section in your book has a video link. So don't forget to watch your videos by going to My Math Lab and looking at the available videos by section and additional help. So don't forget My Math Lab as another video resource to assist you in learning this material. All right, thank you very much.